are physical ports and there are logical ports. So they help us to connect with that protocol or with that application, right? A protocol could be anything. It could be a server configured. It could be an application configured. It could be, anything. You're not required that it is something like application only. It can be anything. So basically it does some work, dedicated work. So for example, we have this HTTP or HTTPS protocol. Leaving apart the yes part of it, which is a security part of it, which will cover no, next. As of now, we'll just look at the HTTP part. Okay, yes part is the security part of it. So let's keep it aside. So considering only HTTP, okay, which stands for Hypertext Transfer Protocol. So this protocol, like every protocol, it is used for, it is designed for doing some specific task. So this particular protocol, that is HTTP, is basically used to the use of this protocol. Okay, HTTP is basically to display the web pages from a client to a server. Okay, the web pages are generally in the form of HTML, hypertext markup language. Okay, so every website, if any web page needs to get loaded into your browser, then we make the use of the HTTP protocol, right? And this protocol basically, it's very simple. So there is a web server. There are many web servers in place, like we have Apache server, Nginx server, Nginx server, and so many web servers are there. So an HTTP protocol will be configured, and that web server will contain the web pages. Okay, so on the other side, we design web pages. The back of the web pages is basically the backbone of the web pages is basically the HTML. Okay, inside HTML we code the Java, we code PHP, and all these other scripts or languages we code in to make it more interactive, to make it look more good and presentable, and so on. Okay, so what happens with an HTTP protocol is basically a request will be sent to the server, and the server will give the HTTP response. Okay, so in this case, the what will be the request here? What is the request in reality? What is the request that will be sent by the client? The request will be basically a URL or a domain. Okay, a web page. So for example, www.cybersapiens.in. Okay, so when you enter this particular thing in the browser and you hit enter, so there is a server where we have configured, and we have designed all the pages and kept there. Okay, so the cybersapiens.in will display basically the home page, and from the home page we can navigate to other pages like contact page, about us page, and so other pages. Okay, so when this happens, the whatever and we have designed in the HTML body, it starts with an HTML body, and you close the HTML body and the HTML tag, whatever is designed there, whatever is been configured there, that gets displayed onto your browser. And there are other protocols also that comes into the picture while we use here, like we have TCP protocol is there, and many other protocols also comes into the picture, but widely it is the HTTP for displaying web pages, for for sending and receiving the web pages. Okay, so I hope this is clear with the HTTP protocol. Now coming to the HTTP and the HTTPS. So all of you might be knowing that HTTPS stands for security. Okay, which means here in the example, if HTTP is used, then the password that is sent will be in the plain text, that is ABC123. Okay, so what can happen is, if any attacker, steals this password, okay, steals this password, then he'll be able to see the password in the plain text. So this particular attack is called as eavesdropping attack or sniffing attack. Okay, this particular attack will be demonstrated to you, I think, tomorrow. I'm not sure the session. Yeah, I guess it is tomorrow, day after tomorrow. There is a session which where we'll be demonstrating how you can sniff a particular packet from the network, and you can see its data, like the password that is being sent. You can actually see this. We're gonna demonstrate it. And on the other, so this is basically risky, right? So this is basically risky. um, Anyone can see your password. On the other side, if https is used, okay, so if the password is abc123, even if the attacker gets the password also, he will not be able to see the password as abc123. He'll see it in encrypted form, okay, or we also call it as a ciphertext, right? So this is basically part of cryptography. Okay, this is basically part of cryptography, and cryptography plays a very important role in cybersecurity. It's one of the very important control, we can say, or a mechanism which exists in cybersecurity. And cryptography again, was been the concepts of cryptography was been used from a very long time back. Okay, from very long time back. If you read through the history of cryptography, you can see that there was a king who had shaved his shoulders, head, and he had written the message on his head. And he had sent the soldier to his another person whom he wanted to convey the message. So back then it used to take a long time to reach from one destination to another destination. So it was traveling by walk, right? There was no other communicating medium. So this person, by the time he reached the other place, he would have hair on his head. He would grow hair on his head, and thus no one would be able to see him. If anyone catches also, no one will see whatever is written on his head. So when he reaches on the other side, the other person who had to read the message, he would again shave his head, and he would be able to see the message. So this is basically a way of hiding the message. Okay, in the this is in the back terms, and in the modern terms, the term cryptography is basically converting a human readable format into a non-human readable format. Okay, that's what cryptography means: converting a human readable text, or a plain text, or a format, into a non-human readable format, so that that information becomes junk. Information becomes waste for that attacker who gets that particular data. Okay, so cryptography basically means converting a plain text into a cipher text, and then from cipher text into a plain text, that is, from a readable format to a non-readable format, as I said. For example, if we have John, and this particular plain text, when it gets encrypted, okay, through some algorithms, in that case, it becomes a cipher text which changes from John to 1 at the rate hash something, and then again it has to be run through the same algorithm so that we get the original text. So the concept is very simple here. So in this case, what will happen is, see here, if the message is encrypted, okay, this person is sending the message to another person, and this message, whatever is message is sent, the message is encrypted. Okay, so if any intruder obtains the message, okay, but its encryption makes it useless for him or her. Okay, so even if the person gets the message also, he will get the junk data, he will not get the actual data. Okay, he will get the junk data. So here is a question for you: what part of cyber security are we protecting here? Okay, in this scenario, or with the use of cryptography, at a very high level, what part of cyber security are we protecting here? Can anyone help me with this answer? In this given scenario, we are protecting something. So cryptography is basically a control. We have implemented this control to basically protect the some the parts of cyber security, which I've said. So, the question for that is, what is cyber security? Cyber security is basically protecting dash 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 of data. So what part of cyber security are we protecting here? uh, No, basically there are three things: confidentiality, integrity, and availability that we are protecting. Always, this is what we have to be keeping in our mind. Okay, confidentiality, integrity, and availability. Whenever anything comes up, we are protecting three things of a data. Okay, so with respect to this particular scenario, what exactly are we trying to protect the data from? Are we protecting the data from confidentiality, integrity, or availability? Is it confidentiality? Yes. So yes, as you said, it is confidentiality. Okay, it's not availability; it's confidentiality, because the reason is, even if this intruder is getting this message, he is not able to know what that message is exactly, right? So this is, we are protecting the confidentiality. Okay, and on the other side, it could be also integrity, but integrity, it's a different case there. Here the major agenda is, he is not able to see whatever is being sent, so confidentiality of that message is been protected. Okay, so I hope that's clear. So talking about the cryptography mechanisms, there are widely two types of cryptography or encryption that is done. One is symmetric encryption, another is asymmetric encryption. Okay, so symmetric, one key; asymmetric, two key. There are two keys, one is public key and a private key, and in symmetric there are only one key which is used. Okay, so let's look at the difference first before we get into the actual working. The difference with symmetric and asymmetric is basically in with respect to the key. In symmetric, one key is used. Okay, in asymmetric, two keys are used, that is public key and a private key. Okay, so key exchange happens out of band through secure mechanisms. In the symmetric key, there is a separate key exchange mechanism that is there. But in the case of asymmetric, the public key is something which is available to everyone. Okay, there are two keys that are used, so the public key is made available to everyone. So with respect to the exchange of keys, the security is more while exchanging the keys in symmetric, while in asymmetric the security is less. Speed is less complex and faster. Okay, it is not complex, simply one key is used, another key and to encrypt, and the same key is used to decrypt. Okay, but in the case of asymmetric, the algorithm is slightly more complex, because there are two keys that are used and there are many other things that comes into picture here. Okay, and it is kindly slower. The use of symmetric is basically in bulk encryption, which means encrypting files and communication paths. Asymmetric, it is used in key distribution and digital signatures. Digital signature is one of the main use. We'll look at this digital signatures part. So symmetric key provides confidentiality factor only. Okay, symmetric key protects data from the confidentiality. It provides the confidentiality factor, whereas asymmetric provides confidentiality, it provides authentication. Okay, authentication with the which is implemented with the digital signatures. All right, and non-repudiation, which is again a concept or a feature of digital signature. Non-repudiation means one cannot deny. Okay, one cannot deny saying that the message was sent by him. So if I am sending any message or an email to another person, I cannot deny that this message was not sent by me. Okay, so because you are connected to the internet, anyone can send message or email or contents on behalf of anyone. Physically, if it was there, then we have the physical signatures, but in online, how do we use this concept of signature? So we have something called as digital signatures, and that's what we're gonna look in the next slides. So symmetric encryption, as I said, it uses only one key is used to encrypt the message, and the same key is used to decrypt the message. Very simple. Okay, one key is used to encrypt and another key is used to and the same key is used to decrypt. Okay, so the algorithms that are used for the symmetric key is basically AES algorithm, which is advanced encryption standard. This algorithm is basically a set of rules that are designed. There are certain step by step design rules which are sent, so that once that input is taken, it will take the key, it will scramble up, and it will generate the output. Okay, so the key is could be like, in layman terms, it could be like A means 1, B means 2, C means D, like that. Okay, so the input, if the input is given as apple, okay, the output will be 1 and P for some letter, number, maybe 15. Okay, P same 15, 1 15 15, L could be 18. Okay, E could be A B C D E 5. So this will be the output. All right, so that algorithm knows what key has used and how it has done the conversion, so that it can reconvert it back. So algorithm that is used is AES algorithm. Okay, the challenge here is key distribution. With this type of encryption, the challenge is key distribution. As I said, since only one key is used, if that key is if anyone else gets to access that particular key, then the entire confidentiality itself is lost. Okay, not just confidentiality, integrity also is lost, maybe availability is also lost. Okay, so the main challenge with symmetric key algorithm is basically distribution of keys. Okay, we have to make sure that the keys are distributed very securely, and that is the biggest challenge that is faced. So next is the usage. Where is this symmetric key basically used? Okay, where is this key used? One of the usage of symmetric keys in the application called as BitLocker. BitLocker is basically a feature for the full volume encryption, which is by default provided by Microsoft Windows. Okay, starting with the Vista versions, Microsoft has given this cryptographic symmetric encryption method application called as BitLocker, which is which uses the AES encryption algorithm with a key length of 128 bit or 256 bit key. Okay, it is used for full volume encryption. So it captures information about the computer's data, including make, model, internal part serial numbers, and uses it to ensure that your drive hasn't been stolen and inserted into another machine. So generally, when organizations, when we are working with organizations, most of the organizations give their company or laptop to their employees. Okay, for doing the for the work purpose, systems or laptops are provided by the company, right? So in this case, when the laptop is given, and especially during the time of lockdown and all, what will happen? Anyone can steal that laptop, right? People live in PGs, um, and people live in some houses and all, so robbery can happen, or they might lose it. So when someone loses it, no one wants that the data that is there, it has been it gets stolen, and they reuse it by plugging it to some other system and so on. So basically, to maintain the confidentiality purpose, most of the companies, or all the companies that have or that need security, that focuses on security, would have turned on BitLocker for their system. So in this case, one key, while locking locking the BitLocker, you have to put one password, and to get it back also, you have to put that same password. So in this way, the BitLocker works. Generally, it is provided for the pro version and the enterprise version. For the home users, I'm not sure if you have it by default. No, you don't have it by default, but yeah, you can get it. download it, but generally for the professional version and the enterprise version they give it for free. Okay, so that is what symmetric algorithm is. And then coming back to asymmetric algorithm, it uses two keys. One is public key, which is known to everyone. Okay, so mark these words which I'm saying. Public key is known to everyone, and second is private key, which is known to the user only. Okay, so one key is used to encrypt and another key is used to decrypt. All right, so if I'm sending a message to from A to B, okay, I need to be having the public key of B, and I'll encrypt this particular message with the public key and I send it. Okay, now only B can decrypt it because it has to be decrypted using the private key of B. That is how the algorithms are designed. Okay, so that's how the algorithm are designed. And this is more secure generally compared to the symmetric, because if one key is lost then it's gone. But here with the use of two keys, the exchange of keys is also simple, and also the mechanism is widely used in a lot of in lot places. Okay, so the usage, if you see, it is used in the web applications. Okay, especially HTTPS. Okay, uses the symmetric key algorithm. All right, or symmetric key encryption is used in the HTTPS protocol. So HTTPS, what is HTTPS? HTTPS is basically combination of HTTP and SSL certificate makes it HTTPS. Okay, so here is, this is one of the implication where asymmetric key is used. We look at the scenario in the next slides on how HTTPS is makes use of SSL, which again makes use of the asymmetric key encryption along with the live scenario. Okay, so one is web applications. All the web applications which uses HTTPS uses asymmetric encryption method. Another usage is basically in the digital signatures. Okay, so we look at the both of these things. So which web applications require an SSL certificate? Which are the web applications that require SSL or HTTPS protocol? Basically every application which process a user data. User data could be password or details in the forms. If you're writing any type of information like your passport data, Aadhaar number, and all these things in a form, then that has to be encrypted. Okay, online transactions, if you're doing online transaction and if you're doing the payment, you enter the card data, right? So the card data needs to be encrypted. Otherwise, if the data is not encrypted, then what will happen? An attack called like eavesdropping attack can happen, where an attacker will be able to steal your data. Okay, how this eavesdropping attack will happen, that will be covered in the next session. There's a separate session, as I said. So coming back, what we have to understand with respect to HTTP is that remember these words: HTTPS is secure, but it cannot be trusted. Okay, so when you visit a HTTPS website, it means that the website is secure. Why? Because whatever data you're gonna send, it is going to encrypt the data before it sends from your browser to the server. Okay, whatever you are sending, it is getting encrypted. So that is how it is secure, but it cannot be trusted. Why it cannot be trusted is something which I'm gonna explain you after the after the next slide, which is where I'm gonna show you a web application scenario. Okay, on where exactly and how exactly the asymmetric encryption works. With the real-time scenario is the web applications, as I said, or websites, as I said. Okay, so if you have any questions, I think please keep it posted on the chat box so that I can answer it in between. Okay, if you need any clarifications and so forth. So basically we are taking a web application scenario here. With this scenario based explanation, it will be very much clear to you on how exactly the and where exactly the symmetric key encryption is used, and about the public key and all those stuff. Okay, that those things will be clear. So please listen to this carefully, and if you have any doubts, please stop me and ask me there itself. Okay, so let's consider that there is a, you are trying to access through your browser you are accessing a website which is a bank. Okay, for example www.bank.com, or it could be accessbank.com, icici.com, or anything. Okay, sbi.co.in. So you open the browser and you want to do some online transaction. Okay, so you open the browser and you put the url, that is bank.com. So on the other side, this particular server might be somewhere else. It might be in us, this might be in russia, this might be in maybe in delhi, this might be in some other place. Generally most of the servers are located in the us country itself. Okay, either in india or in us. That's the place where all the servers are stored. So when this web server receives a connection, when you send a request, http request. Okay, so through the browser to the bank server, what happens is uh, you send. Okay, and when you send some uh, uh, a protocol is used, which is TCP protocol. Okay, control protocol. All right, and through transfer control protocol, a connection is established. Okay, and when connection is established, some exchange of information happens. Okay, so basically TCP protocol is used in the web applications on the websites generally. Okay, so TCP does that three-way handshake, as you know. Three-way handshake is done and then connection is built. Okay, so once connection is built, these two people, before even the pages gets loaded, these two people, that is the browser and the bank server, will exchange some of the information. Okay, so this is part of the TCP protocol. And then we have the UDP protocol also, that is user datagram protocol. Websites use TCP protocol. Okay, the main difference with TCP and UDP is that TCP waits for the acknowledgement, and whatever it receives, it will display the packets in the random in the sequence wise. Okay, so if the packets 5 is received first, it will wait for packet 1 to receive, and then the content of packet 1 is shown, and then packet 2, packet 3. This is the reason why you always see that website is or website loads always from the top. Okay, I'm not sure if you have all anytime seen, you have anytime noticed, but you will never see a website which will get loaded from the below, from the side, or from between and all. Websites will always get loaded from the top. Why? Because it uses TCP protocol. Okay, coming back to our scenario now, coming back to our scenario. So TCP is used and exchange of information happens. So browser gives some information to the server, and server gives some information to the browser. Okay, so browser or client information is shared, that is IP address, system details, operating system, which browser, session details of the user, cookies are shared. So these are some of the information which browser will share to the server, because server needs to know, right, from which IP address, what is the user, the system details of the user, that is the hardware details it shares. Then it also shares the operating system version. It also shares what browser, through what browser, version of the browser is also shared. Then session details or cookies are shared by the browser to the bank server by default. So these are some of the information which is shared by the browser to the bank. Okay, so this happens when the initial exchange of information happens, when the initial connection is built. After that, soon after the connection is built, exchange of information happens. And what is the information which bank server will provide? Bank server will provide its server information, which includes public key. Okay, this will share lot of information, like its the other protocols that are used. Okay, like initially it will share the SSL certificate. Along with SSL certificate, public key is shared. Okay, so when the initial exchange of information happens, public key is shared. All right, so when the statement which I said, public key is something which is known to everyone, so by default it is not known to everyone. Okay, it is basically shared when the connection is made. All right, so never get confused. with the statement that public key is something which is known to everyone, it means who are those everyone? No, it's basically it gets shared when the initial connection is built. Okay, so server will share its public key along with the other details. All right, and when this and basically public key is shared only when HTTPS is used. Okay, if the website is using HTTP, then public key, the concept of public key will not come into the picture because it doesn't use public key. Okay, so public key is shared in case if HTTPS is used. All right. Now, what will happen when the initial connection is built? Public key is shared. Next thing is the requested page, that is bank.com page, is shared to the browser. The browser will display the web page of that bank. Okay. Now here, when this thing happens, next thing is basically data is being sent. Okay. What data? Basically, you are into the home page where you have to first log in, right? After logging in only you can do all the transactions. So considering that you're logging into the website, so you provide the login credentials, that is your username and password. Okay, now when we're talking with the banking applications, please remember that usernames and your passwords both are very sensitive, very critical information. You should never be sharing neither your password, which is obviously by default, nor your username or your email ID which you have used. Okay, always remember this has to be kept secret. So when you're doing a banking transaction, username and password are both very much crucial and they have to be protected. All right. So login credentials you enter. Where do you enter this? You enter this in the login form. Okay, in the login form you have entered your username as Robin123, and the password you enter here, Robin123. You have entered the password. Now this particular credential has to be encrypted, isn't it? Why? Because it's a banking website. No, every banking website has to encrypt its data. Otherwise, eavesdropping attack can happen, sniffing attack can happen, and anyone can see your password. All right. So protect the confidentiality, we have to encrypt this. Okay. Now, when the encryption has to be done, it has to be done by the browser. Okay. So what browser will do? It will encrypt this particular data using the public key of the server, which is provided to the browser during the initial exchange of information. Okay, and when it is received by the server, it will decrypt using its private key, which is stored by itself. Okay, so this particular method uses the SSL certificate or TSL certificates are used here, and that certificate will have the private key and the public key. Okay, and this person will, what it will do, it will basically decrypt the information with its private key. Okay, so this is how the exchange of information happens, and this is how the public key is used and private key is used to public key is used to encrypt and private key is used to decrypt. If anyone gets access to this, unless and until that person knows what the private key is, that attacker will not be able to decrypt this data. Okay, now to show you with the real-time scenario, if you ever want to look at a particular SSL or a public key, okay, so this particular lock system here means that it is secure or it is using an SSL certificate. Okay, so you have to click on this key. Okay, when you click on this key, you have something called a certificate. Okay, so click on this certificate, and when you click on the certificate, you will be able to see the certificate is issued to google.com, and it is issued by GTSCA101. Okay, so these certificates, SSL certificates or the public key or private key, which comes with the SSL certificates. So these SSL certificates are provided to an organization by someone called as certifying authority or CA. Okay, a CA is like the how do I say, it's like an office. Okay, there are CAs appointed by the ministries, the government regulations. They have appointed the CA, certifying authorities, who are only support who can provide you the certificates. Now, all right, now if you want to look at the validity is also given here. If you look at the details here, or if you look at the certification path also, so this has been given by Google Trust Services, that is global sign root CA to GTS. Okay, and it is given to the server google.com. All right. Now if I click on the details here, you can see that signature algorithm, this is hash algorithm. We'll come to the hashing point in the next slide. For now, what is important for us is the public key. Okay, so if you see this, this is basically the public key of google.com. Okay, this is where it resides. So when the initial connection is done, it will send the public key to it. So for example, if I go to Microsoft website, there also we can see that the key is provided. Sorry, not cookies. This is a certificates here. It is issued by Microsoft RSA, by the RSA company. So here it also has the, when the initial connection happens, it has shared the public key with me with this, which is 2048 bits. Okay, so this is the public key. So every company will have their own. So this is basically provided by DigiCert. Okay, DigiCert is basically a certifying authority. So in order for DigiCert, okay, DigiCert is the company. Okay, one more thing I would like to share an awareness here, since I have come across this. Always whenever you are using Google search, no, when you search for the Google and you get the result, never click on this ad that is shown. Okay, never trust these ads, because I can make a website with the name digecert.com. Okay, that I'll make it e, and I'll advertise it by paying Google some 2000 4000 rupees, and Google will show that result here. Okay, so you will not be entering the actual site, but you will be entering the site which I have advertised through Google. So it is not recommended to click on the or rely on the advertisement ads that you get after the Google search. Okay, so coming back, DigiCert is the company which provides SSL certificate. So in order for a company to get a digital certificate, they have to provide their identity. Okay, they have to provide their identity. In that case only a certificate will be this is issued by Hydrant ID SSL. That's the company which has been, the root CA is basically Quo Vadis is the company that is provided to the Hydra, and then they have provided to Cisco.com. Okay, so Cisco have to provide these company their identity, their proof. What is the proof? The proof is basically their company registration certificate, GST certificate, and all the certificate will be provided. Then only they'll get the SSL certificate. Now coming to my last point, which I said, that is HTTP is secure but cannot be trusted. Okay, as I said, HTTPS nowadays everyone will believe that okay, this is HTTPS, I can believe it. Okay, so one thing what we have to remember is this particular thing. Okay, if it is a genuine website, if it is cisco.com, you have to verify this by going to the certificate and seeing whether this is provided to cisco.com or not. Okay, similarly, if it is microsoft.com, you have to verify this, but whether it is provided to microsoft.com or not. Otherwise, like for example, in case of my company's website, that is cybersapiens.in, if you look at this, what we have done is we have not provided any we have not taken the certificate on the company's name. Okay, so this has been issued to sni.cloudflaressl.com. Okay, so it is nowhere you can see my company details here, like cybersapiens. You don't see it because we have not taken it from by providing our identity. All right. So what I can do is I can make a website which looks same like Amazon, Flipkart, or Adobe or Java or something like that. Okay, and I can add an SSL certificate to it even for free of cost, and also by paying minimum of 100 rupees. By paying 100 rupees, I can get a SSL certificate to my website. Okay, nowadays attackers are, all the phishing websites that they are creating, they are adding a SSL certificate to it. Why? Because they know that people are trusting it. Okay, so it cannot be trusted. This is what my statement I wanted to convey. SSL HTTP, yes, it cannot be trusted. Please make sure you verify the SSL certificate before proceeding. Okay, so I hope this was clear to you about the asymmetric encryption with the example scenario of how the public key is used and shared. Next is about hashing. Okay, what is hashing? Hashing is basically converting a plain text into a non-human readable format. Okay, converting a plain text into a non-human readable format. But the fact here is that the plain text cannot be regained back to its original site, original text. Okay, so once a value is hashed, then you cannot reverse it. It is not reversible. Okay, so basically there is a plain text and there is a hash function used or a hash algorithm that is used. Okay, so when this is used, then a hash value is formed. Okay, so this same every time this particular plain text, same text, like if it is Robin, if it is run through algorithms like MD, that is message digest, or SHA, that is secure hash algorithm, every time the text Robin is hashed using MD5, it will generate the same output unless and until the algorithm is different. Okay, if I put Robin dot after n, I put a dot there. Okay, then the hash value will get completely changed. So this is the mechanism of hashing. The difference with hashing and encryption is that hashing is one way, okay, and encryption is two way. So once you encrypt, you are able to decrypt that also, but in hashing you're not able to decrypt that. All right. So where is this hashing used now? Let's take a look at it. Where exactly is this concept of hashing used? Because it is not getting reversed. No, what is the use of hashing and how it is used? We'll take a look at it. Basically, hashing in the traditional world, hashing is used for the purpose of authentication. Okay, so authentication. What is authentication? There are three terms which comes into the picture in cybersecurity: identification, authentication, and authorization. So authentication means what? Authenticating someone. Okay, giving the access to someone is called as authentication. All right. So like in this case, I am authenticated to share my screen. But if any one of you tries to share your screen, you will not be, I'm not sure. You might have the option to do it, but you are not authenticated. You will not be given that authentication. Okay, to do it, right? So that is authentication, to provide the access or to give the permission. All right, that is called as authentication, and authentication is done by three major ways. One is something you know, something you have, and something you are. So something you know is basically password, your pin or something. So you give your password, you are given the access, you are authenticated. Okay, something you have is basically your ID card. Okay, swiping the ID card, you know, you swipe the ID card and then you are given the access. So that is something you have, ID card. Or there are physical authentication based cards are there. Okay, there some of the companies provide some different type of cards, so that in order for them to access a server room, they have to swipe with that with that card only, then only they can access. Okay, and the third thing is something you are. Something you are is basically your biometrics, your retina, and what else, your fingerprints. Okay, so so these are the, or maybe your voice. These are the this comes under something you are. Okay, so when we are talking about a two-factor authentication or multi-factor authentication, when you're talking about two-factor or multi-factor authentication, it should be either of these, any two of these. Okay, so two-factor authentication doesn't mean that you're using a password and a pin, because a password and a pin is something you know. Okay, two-factor authentication is where you have something you have and something you know. That is OTP. OTP is something you have, okay, which is provided to you. It is not your own. It is not something which you know. Okay, so password and OTP makes two-factor authentication. All right. Or while in the banking thing and all, physical banking thing, they take your fingerprints. Something, Aadhaar card number you provide, or an OTP you provide, and then take your fingerprint also. So something you know, something you are, something you have. And when we're talking about multi-factor or two-factor authentication, it has to be either two of these three things. Then only you can be calling it as a multi or two-factor authentication. I hope this is clear. Now coming back to our authentication purpose, hashing is basically used for the authentication. Okay, so what happens in the what's happening in the current world is that whatever passwords you give, basically passwords you give for authentication, get authenticated. This is something you know. Okay, so this password is stored in a plain text in the database. Okay, very serious issue this is. Nowadays most of the companies, or till date most of the companies or the web servers are storing passwords in the plain text. So what is happening, if I am able to access the database of that particular company, of that particular server, I know their passwords. Okay, so in that case, it has to get either encrypted, either it has to get stored in encrypted form or in hashed form. Encrypted form we cannot store it because that's a different concept, that it will not work good, or it is not suitable for the authentication purpose. So what's happening is nowadays all the passwords that you give, it is getting converted into a hash value, and the hash value is stored in the database. Okay, so that hash value is stored in the database such that if someone gets access to this database, they will have the hash value, which is a junk value and not your actual data. All right, so this happens when you register, and you give the password. That plain text of that the password is not stored in the plain text, it is stored in the hash value when you register. Now registration happens, next is you have to log in. So while logging in, what will happen is, when you log in, you give the password. Okay, like your password is password at the rate 123, you give that password, the same password you are given here, password at the rate 123, but here a1 b1 c1 d1 is stored instead of password at the rate 123. Okay, so when you give this password, what the system will do is, the system will generate a hash value the system will generate a hash value of the password that you give, and it will send this hash value to the database of the password. Okay, and if it finds that the hash value is available in this particular database, it will authenticate. Okay, this will authenticate, because password at the rate 123 will the hash value of password at the rate 123, if it is run through MD5, the hash value will always be the same in this particular system. Okay, so even if instead of password, if they put RRD, in that case the hash value will be different, and then it will not get authenticated. Okay, so this is where one of the way where hashing is used. So it is recommended, even when you are working with web applications, when you are working with web development part and all, please make sure you ask your students to make a habit of hashing the passwords and keeping it. Okay, otherwise there is a huge risk. So this has to be done by the developers. Okay, so the digital signatures, as I said, one is the it basically protects, it is used for authorization purpose. Okay, or authentication purpose. And next, sorry, very sorry. Coming back, I think this till here it is about hashing. I hope this hashing is clear. So hashing is used for authentication purpose, and this is the real-time implication where hashing is used. Okay, the next topic is digital signatures. All right, the next topic is digital signatures. Now digital signatures are widely used, they are widely used, especially in the government sides and all. Digital signatures are used. Okay, especially when documents has to be sent in an online form. Okay, if I have to send you a contract or a document, I have to digitally sign it. Okay, so the main purpose of digital signature is to protect the integrity and to protect the non-repudiation. Okay, integrity needs to be protected, obviously, because whatever contract details I am sending, it doesn't have to, it has to be as is, no one should modify it. Okay, second is non-repudiation, which means that the contract which I have sent, tomorrow I should not be denying that, hey, I had not sent this is not mine document. Okay, so in order for me to authorize it, okay, or in order for me to authenticate it, authorize it, we use digital signature. So I am authorizing this particular document and I am sending it. Okay, one is authorization, and second thing is the protecting the integrity. So these are the two features which are provided by digital signatures. Okay, now let's take a look at the working of the digital signatures, how this uh, digital signatures work. As I said, it is used widely by the government officials nowadays, especially with the with the use of the, wherein digital India have has come up. So if you want to download your income certificate, or if you download your RTC, land records, if anyone has downloaded your land records from the official sites, you can see in the below that it is digitally signed. Digitally signed means it is authorized by a person, by the authorized person, it is authorized. Secondly, this particular document is has maintained the integrity of the data. Okay, so these two things are there. Just a second, let me take a sip of water. Okay, looking at the working of the digital signature, how exactly it works. With the scenario, I'm going to explain it here. So there are two parties, Suresh and Ramesh. Okay, so Suresh wants to send a message to Ramesh, which is digitally signed. How does he do that? Let's look at it. Okay, so first thing, Suresh has a message. Okay, this message is what he has to digitally sign and send to Ramesh. Digitally signing means authorizing and protecting the integrity. Okay, so by authorizing, he cannot deny that this was not sent by me. That is non repudiation. Okay, so we have a message. So what happens in the digital signature is, this message first it gets hashed. A hash value of this message is generated. Okay, we call it as HV1. Okay, so first thing what happens with this message is that it's basically an algorithm again. Okay, digital signatures, it's an algorithm and a program that runs through. So when that program is run, this message is taken and that message is first hashed, okay, using some hashing function. So we have HV1, which is the hashed value of this particular message. This message HV1, okay, this HV1 is being combined with the actual message. Okay, so this HV1 is added, another value is added, which is the original message is added, and we call this as M1. Okay, so M1 is basically the original message and HV1, both values are there. Original message is also there and the hash of this message is also already also there. Okay, two things are there in M1. Now this M1 will get encrypted. Okay, this M1 will be encrypted, and the output of this encryption, will name it as sorry, we'll name it as E1. Okay, and the encryption is done using Suresh private key. Okay, don't get confused here. It is encrypted here using Suresh private key and not public key. It is Suresh private key is used in order to encrypt the message here, that which becomes E1. Okay, now this E1, this E1, which is encryption of M1, which is combination of H1, HV1 and the original message. This is E1 plus a certificate is added to it. Okay, like an SSL certificate. I'll tell you what that certificate is. Okay, and a certificate is added to it. This becomes digitally signed message. Okay, so this particular message could be in a PDF form, this could be in a Word form, this could be in an email form also. Okay, so all these things are confirmed and message is given to the tool, which makes a hash value of it, combines with the original message, encrypts with the sender's private key, and then it adds a certificate to it, which becomes a digitally signed message. Now this digitally signed message is sent to is sent to Ramesh. Okay, so Ramesh has these things now. Now what will Ramesh do? Ramesh will have, one thing is the certificate, we'll keep it aside. E1. Okay, so Ramesh will take the E1. Okay, which is basically the E1 is basically encrypted. So the first thing that Ramesh has to do is decrypt this. Okay, so in order to decrypt in order to decrypt this E1, okay, what is required? Now this is encrypted using Suresh private key. Okay, so we are using asymmetric algorithm here, that is private key and public key, two keys are used. Okay, so in order for Ramesh to decrypt E1, okay, which is encrypted using his private key, Ramesh would need Suresh public key, right? So Suresh public key is used, okay, uh, to decrypt. From where will Ramesh get the Suresh public key? He will get the public key from this certificate, okay, SSL certificate, which I showed no in that asymmetric. From there the same kind of concept is used here, and from there the public key is sent. So this particular digital signed message will have the E1 plus the public key of Suresh itself. Okay, now if Ramesh is able to decrypt this E1 using Suresh public key, it means that this particular message is sent by Suresh only and no one else. In this way, we are ensuring non-repudiation here. Okay, non-repudiation means now since Ramesh is able to decrypt it, Suresh cannot tell that, hey, this was not sent by me. So this particular guy has authorized it. So this is basically the part of authorization. Okay, now moving next, when Ramesh decrypts E1, he will have two things. One is HV1 and M, that is the original message. Okay, now non-repudiation or authentication is done. Next is to see the integrity. Okay, so to see the integrity, what Ramesh will do, Ramesh will generate a hash value of M. Okay, he will hash this M using the same algorithm, using the same method, which is also embedded in this certificate. So this certificate, Ramesh will be knowing what method this guy used to hash it. Okay, so hash value will be generated, which is HV2, that is hash value 2, and this particular guy will compare HV1 with HV2. Okay, as I said, any value, any input given to a hash algorithm generates a particular hash value every time. The value will be the same if the input is same. Okay, so if this matches, then integrity is also obtained. Okay, so this is basically the working of digital signatures. All right, I was not able to get any certificates where I digitally signed certificates where I could show you, but if you ever get to download any PDF from the government or any officials, especially with the GST and all, you get this with the GST filing, or with RTC when you download and all. That time if you open the PDF, you will get an option to sign it digitally. Even Aadhaar card also, if you download the Aadhaar card, you will get that digitally signed. If you want that tick mark to come, no, you have to run that digitally signed message. Okay, so when you run that, this is what happens, and non-repudiation and integrity will be checked. If they see that this particular decryption doesn't happen, then that particular document will not get digitally signed. It will tell you that there is some changes that have been done. Okay, and it will not allow you to use that document basically. All right, so this is the concept of digital signatures. I hope this was also clear to you. Going next is the concept of steganography. Steganography basically means hiding data into another data. Okay, it could be from image to image, image to video, or image to audio. Okay, so when we are hiding a data into another data, or hiding a digital data form into another digital data form, we call it as steganography. It could be anything. Okay, as I said, You can also hide a exe file into an image. You can also hide image into an exe file or anything like that. Okay, so how this works is basically, see this picture here. Okay, this picture, if you want to hide it in another picture, into this picture, what will happen? It will break the steganography algorithms or the concepts. It will break these picture into small parts. Okay, and it will remove some of the parts from this particular image, and it will insert that pixels or zeros and ones there. Okay, all right. So these will be the small minute changes which we humans will not be able to see, and that's the speciality of steganography. Okay, humans cannot see it because it works on pixels and everything is zeros and ones. Okay, some bits of zeros and some bits of ones are removed, and another the bits and bytes of another image is put there, making it invisible for the human eye. That small minute changes is something which we cannot see at all. Hmm? So we'll use a tool called as OpenStego. This is the tool which we are using for demonstrating the steganographic concepts. Talking about the tools, actually, I'll be sharing a link with you where we have all the tools. A repository of tools are there. Okay, so you can use this link to download the tools from that. All right, so if you click on it, we have all the tools which are required for you. Sorry. Well, I think just a second. I think this is the tools actually. I'll have to share this particular thing. Let me share it with you. Copy link. Okay, this one. Okay, I'll be posting this in your WhatsApp group as well. So this particular link has all the tools. Even OpenStago is there. OpenStago, Kali Linux is there, which will be covered for you soon. VirtualBox is also there. Bobsuit, which will be covered. Vega, and all these tools which will be covered in this workshop. Most of the tools are here. If you need any other tool specifically, please let us know. We can provide you those tools. Okay, so installation of the tools are not covered. We do not we never cover the installation part of it because installation is very basic thing and it is very easy, so we are not going with the installation part. Okay, so you can easily install. Using it is what we gonna demonstrate. All right, so the exe file, when you download from here, you have to directly run it and you will be able to use the OpenStago tool. So OpenStago is the one that we're gonna run here. Right click, run as administrator. Okay, so this is basically the tool here. Okay, where we have hide data and extract data, two things. Okay, hide data in harmless looking files. So as I said, steganography is basically hiding data into another data form is called as steganography. Now what I'm doing is I have already created a folder in my drive. Okay, so I have a image file here. I want to send this image file. I want to send this image file to another person. Okay, where they do not want to see it by hiding it. So what I'm doing is I'm creating a Word document, or else what we'll do is, all right, I'll do it in the other way. I am writing a secret message here. Okay, uh, secret message here. This particular file has secret message. Okay, okay, so this secret message, I want to share this particular secret message to another person on the internet. Okay, now if I send this directly, that person will be able to see it. Even if I encrypt also, encryption decryption can be done. Okay, and hashing also, the actual value of the hashing can be found. I mean, it is not reversible. Hashing is not reversible, but there are other methods or mechanisms where you can find the hash value of a particular input. You can find the actual value of a from the hash value. Okay, the same way. So I've created a secret file. Now I want to send this secret file to another person. Now what I'm doing is I'm going to hide it in this particular image. Okay, so this particular image, I've already seen it. Okay, this is how the image looks like. So what I'm doing is, I have to select the message file here. Okay, this message file, I'll have to select the message file. Let me go to the stego. Okay, so message file is this. I'm selecting the secret. This is the message file. So we are hiding a doc file into an image file here. Okay, and the cover file is basically the image. Okay, cover file is basically the image here. I'm opening this. Okay, and the next is open output stego file. Output stego file means the output file where you want that output file to get stored is this. So I'm gonna name this as output. Okay, I'm gonna name this file as output, and I'm gonna open it. Okay, so the output file, the stego file will be in the name of output. Okay, so the next thing is we also have another option to uh, protect this with the password. So I can give any password like 1234. This is an additional layer of security that I'm putting 1234, so that even if anyone gets this also, they will not be able to get the actual file because I have set a password there. Okay, so I click on give the password and I click on hide data. Now the processing is happening. So it is now this particular you can see message has been embedded into the cover file. So it is successful. Okay, so I click OK, and when I click OK, we can see here that the output file is generated. Okay, now the cover file was 69 KB and the output file is 2.3 MB. So the size has changed. Okay, so since this OpenStackGo is a free tool and an open source tool, we have a lot of limitations. But if you go for high version and paid tools, there are tools, and this particular tool can only hide in a image file only. You can't use the cover file as a video. You can use only image file as a video. Okay, so if you want for a video or audio, there are different tools which are used. Okay, if you want to hide an exe file also, there are different tools that are used. Okay, so let us open this particular file. Okay, let's open this particular file, and this is the output file, this is the cover file. I'm just changing it. Okay, I'm just changing it on the top. If you can see, the names are getting changed, cover and output. Okay, hardly you can make any difference here, right? Hardly you can make any difference. Even if you zoom also, you will not be able to rectify the changes. Sorry, what am I doing? So even if you try to zoom it out and see the file, where is this? This is cover jpg and this is also cover jpg. Okay, so you will not be able to find any kind of changes here. Everything would look perfectly fine. Okay, none no you will not be able to see anything here. All right, it will look exactly like the original file itself. So this is the use of steganography using OpenStago. You can try it out by downloading the tool from the repository that is given. So where is this steganography used? Where is this steganography used? Steganography is used, one is military, in the military force, especially US military and all. They have been using steganography from a very long time, basically to send confidential information. Okay, to send confidential information, steganography is used by the military people, where they hide their messages and all, and they send it. Okay, one is military. Second thing is hackers. Hackers use the concept of steganography to spread malwares. Okay, to spread malwares, hackers use the concept of steganography. So what will happen here is that any hacker, he can hide a malware into a Word document or even an image file also. Okay. So talking about malware, what is malware? Malware is just a code, a piece of code, a script. Okay. The script could run even by clicking on that image or even by clicking on that Word document or opening that Word document. Okay. An hacker can write a script wherein he will mention when user opens, run this particular thing. Okay. When you open any document, that malware will run and it will affect your system. That is why we have to be very careful while downloading contents, data or applications from the internet. Okay. And that's why antivirus helps us in identifying, but it doesn't help you completely. We have to take care of it also from our side. We can't depend or rely on antivirus. Just because you have antivirus doesn't mean that you go on downloading things from the internet. So be very careful. Okay. This is a very common thing. We demonstrate on how you can create a malware and insert it into a steganographic file, and how it work in an advanced workshops and all. So sometime if we have any advanced workshop, we will let you know. You can get a hands on it. The third thing where steganography is used is basically terrorists use, basically in the 26/11 attack that happened, the Pakistani terrorist group used the steganography method to exchange lot of information. Okay. This, the Indian government came to know after when the attack happened, when the analysis and all were being done. It was found that they used steganographic method in order to transmit their data, and they they generally use the pornographic content. Okay. Terrorists use pornographic contents like pornographic porn image or a porn video, or a movie. They insert their messages into these contents and they send it. Okay. And hackers also use pornographic contents only to spread the virus. So it's very dangerous to access any pornographic files, any type of files. Okay. So coming back to the terrorist point, yes, terrorists use it to spread message. And this NASA and US military defense and all, there is a team which tries to analyze pornographic contents and other contents and all, to find whether those images or videos have any malware hidden it or information hidden in it or not. Okay. So this NASA people and this US military and all, they have very high end applications from where they can find it. Okay. So this particular concept can be given as a project also to your students, where they can make a program which will identify whether any input file has a hidden message or not in it. Okay. So this can be done. And I think I haven't done the reverse part of it. No, I'm very sorry for it. I missed to do the reverse part of it. So I'm gonna show that also. So very sorry. Stego, when I go open Stego and as administrator. So the next thing is basically to decrypt or to get the original message back. So I have hidden it. Now I have to extract it. Okay. To extract the input Stego file, I'll choose this secret file. I have to choose the secret file. Sorry, the output file. Okay. The output file and the output folder where you want that file to get stored. So I'll give it here only in that same folder. Okay. And then it will, I have to enter the password. Password is 1234. Without entering the password, I cannot extract the data. Extracting the data. So it is secret is already existing. Okay. So I'll give it as no, and let me change it to secret one, and I'll do it once again. Okay. So message file is successfully generated. So secret is the file which I was able to get banned. So you can see there's no modification happened here. Okay. And moreover, the size is also, I think, should be the same. Yeah, 11 KB and 11 KB, the size is almost the same. Okay. So if you see the file size of the actual one is 69 KB, 69 KB plus 11 KB, it's around 170 odd KB, but the output file is 2.63 MB because it has a password also, and other things are also been put there. Okay, so it's not just the hidden message, it has lot of other contents also. That is why the size is more. Okay, so the difference with this two so I hope you have understood now where this steganography concept is used, widely used by military people, hackers and terrorist groups. The next thing is about the difference with steganography and cryptography. Cryptography is a technique to convert the secret message into another human readable form. Steganography is a technique of hiding the message. Cryptography is a kind of known communication. Steganography is a hidden communication. So you never know whether anything is hidden or not. Whether anything exists or not. So it's basically a hidden one. But cryptography is a known one. People know that okay, this message is being sent and this message is encrypted. But when a steganography is used, people never know that something is hidden in it. Okay, and that is where it is dangerous. The final result obtained is known as ciphertext, and the final result obtained is known as stegomedia. So these are the differences with steganography and cryptography. So today we have learned about cryptography, about the HTTPS certificate and the SSL certificate, basically with respect to cryptography. So I believe it was helpful for you, and you can utilize this for demonstrating to your students further and show them that how exactly the SSL certificates and the public keys work. And next we discuss about digital signatures and hashing function, where hashing function is exactly used, and for what purpose. And then we looked at what is that, digital signatures, how digital signatures work with a scenario based explanation. I was not able to find any file as such, so I have not show you the actual working. But if I get anything like that, I'll try to make a video and I'll send it in the group, so that you can access it later for that digital signature PDF file that I was saying. If I get, I'll make a video and I will send. Okay. And then we saw about steganography. So that's it for my session today. If you have any questions, please let me know. Please post your questions if you have anything. How audio steganography works? Ma'am, the concept of audio steganography can works exactly like the same concept here, but in the case of audio steganography, there are no pixels. There are no pixels. There are the other concept that comes there. So they're also same. You might get some slight disturbance would be there, but those disturbance would be not heard by you. We cannot feel that disturbance. And moreover, an audio file, they can make it a big larger also, so that the actual media doesn't get affected there. Okay, so the original audio will be there along with the original video. In the back end, they'll add and hide the file, so this file will not affect the original video. So nowhere they are tampering. Okay, but in the case of images, they are tampering the pixels. Okay, but here the pixels or the contents are not tampered, but they are just hidden. So there are tools which will do the audio steganography also. Can a general good morning pic message sent through social media or WhatsApp message can be an steganographic image, or can be? Yes, definitely, sir. It could be, but this WhatsApp has certain features, has certain features enabled, where it identifies any malwares and all. By default it has some features, so you cannot actually send a basic malwares and all, you cannot send. But if a hacker is having a very high level skills and all, then they can definitely bypass this mechanism of the WhatsApp and social media what they have implemented, and they can still send media I think there was already an attack in 2000, last year was 2020, 2019. There was an attack that happened in 2019 where image was being circulated, and that image was having some certain malware wherein it crashed your WhatsApp. Okay, it used to crash your WhatsApp, and within 3-4 days WhatsApp rectified it, and they implement, they had their they made their security strong, and then after that people were not able to forward that image at all. So yeah, these things have happened, sir. And yes, answering to a question, it can be done. It could be a good morning pick, also a good night pick also. Any software for making hash, Ajay sir, I would share that to you. Let me just make a note of it. I'll share the software with you for hashing purpose. uh, just a second. So there are softwares like HashCalc, and many softwares are there. So let me just make a let me just note it down, and I'll make a list of the hashing tools that you have asked for, and I'll send it in the group. Okay, hashing tools, because there are many tools. That is why. So it's better if I send it to you at once. Um, Next question: how to do a digital signature to a document? How can we do it? There are basically tools which are available. Where where you can file, where you can sign a document with the digital signature. For that you would have to provide your identity and all, just like how I said, for a website, if it needs a particular SSL certificate, they have to provide the identity. So in the case of digital signatures also, you need to provide your identity, so that you get a private key and a public key and all those things. So there are methods. I will share this also, Karthik sir, to you, about the tools for digital signatures. I'll send it to you over, sir. There are many such things, so I'll share it to you in the WhatsApp group. You can use it. Is it safe providing our identity, sir? Then, yeah, it is. It is provided to to the authorized people only. No, they are the companies. Like if you want to get an PAN card, you have to submit your documents to the government officials, right? Talking about safety, see, I can't guarantee you that they are gonna keep your identity safe, but yeah, you have to provide that. For the Aadhaar card also, you have provided your fingerprint. You have already provided your photos and marks card and all those things. For the PAN card also, you have already provided. So you have to provide for that. In this case, these are companies which are approved by government, so you can trust them on that basis. But always remember, there is nothing which is 100% secure. Okay, so that thing is always there. All right. Yeah, so these two things, hashing tools and digital signature tools, I'll share it with you in the WhatsApp group. Anything else if anyone has? Okay, Malvika ma'am, over to you.
Thank you, Mr. Robinson D'Souza. This session on advanced cryptography and steganography was so very informative, where you touched on the real-time implications of encryption, hashing, digital signature, and then demonstrating the steganography concepts. You were so clear and explicit in your delivery, and which is very obvious, in the number of queries that were posted. Thank you, sir.
Thank you, ma'am. Goodbye, everyone.
Thank you, dear participants. So the next session would be at 2 o'clock, and that would be on ethical hacking. Yeah, that would be on ethical hacking. That is, ethical hacking phases with the use of tools would be covered, and that would be taken up by Mr. Shashidhar Patkar. So see you all at 2 o'clock. Thank you. I've shared the attendance link for the session 8, both on WhatsApp and in the chat box. Thank you.